Hi guys, welcome back to the advanced networking video. So during this video we're going to pick up where the RHCE module left off, right? For you guys who took the RHCE module, you know that you probably went through some basic configurations for your network. So this one in this video we're going to do some more advanced configuration for network interfaces. So as usual, we will start discussing our toolbox. This is going to be the list of tools that you will need to complete this the task on this video. Then we're going to talk about GeoStack. Right? GeoStack basically is taking your interface and configuring IP version 4 and IP version 6 address. So before, I'm not going to get too into the IP version 6 theory, but I would just touch on a couple of rules that we have as part of the IP version 6 architecture. So we'll discuss it as well very briefly, and then get into go to the lab and start working on the configuration. And then we're going to talk about network teaming, which is an evolution of the previous bonding configuration that we had on previous version of Red Hat. And by the way, Red Hat Enterprise 7 still has support for network bonding, but I reckon that eventually network teaming would replace it. So we're going to talk about it and show you how to do a configuration and configure a team. Then bridging. So we're going to have a discussion about network bridging and do a configuration network bridging and show you how to create your bridge and add interface to your bridge. Then I'm going to talk about a more advanced configuration, and it's just I just wanted to include it because this is a configuration that's not supported by the network manager. So in case if you go to a client and in real life you want to have that kind of configuration, so it'd be it's good to know how to do it, particularly for those of you who work with virtualizations and whatnot. So, but we talk about it when we get there. And then I'm gonna, propose a lab that you can do by yourself, so to practice some of the stuff that we're gonna discuss today. Now let's talk about the toolbox. For this video, I included, if you see, I included the first three tools, links to to sites. The first one is the System Administrator's Guide, and then I included two links for IP version 6. For those of you who are not familiar with IP version 6, there's some material you could read just to familiarize yourself with it. The first one is the protocol specification for IP version 6, and the second one talks about the IP version 6 addressing architecture. So I recommend you go and if you need to refresh on IP version 6, or if you have to learn IP version 6, go to those sites and take a look. Then after that, we talk about by the way, before we move forward, the first three tools are not available in your exam. So if you're getting ready for your RHCE exam, just remember, you're not going to have those three links available to you because you have no internet access, as far as I know, right? So for your RHCE exams, you need to assume that you will have to be able to find your way around the configuration using the tools that come, with Red Hat, and using the documentation that comes with Red Hat. The next tool that as part of your toolbox is the Network Manager Text User Interface. I really like this tool because it's graphical and it lets you create configurations fairly quick. So we're going to go through it and show you how to do some configuration with it. And then is the Network Manager Command Line Interface, which is obviously is a command line tool that you're probably familiar with already, but I haven't been very successful doing teaming and bridging using the Network Manager Text User Interface, although there's some documentation that show you how to do it. I prefer to do it with a Network Manager Command Line Interface, and I will show you some places on some man pages that you can go to look for examples, and it's a simple tool anyways. I think every system administrator should be familiar with the nmcli. Also, if you're doing scripting, it's a very good tool for scripting. And then we the next 4 tools, I'm just going to show them to you right now, although I'm going to use them as we go through the video, but I just want to take a quick stop here and show you the next 4. The first one is the man page for an MCLI. The reason why I included the man page for an MCLI, because obviously it's a tool that we're going to work with it a lot, and I suggest you go in and an MCLI. I suggest you go in and get very familiar with it, right? So you do have some some explanation about what an MCLI does, and these are the basics, and some of the commands that you can run with it. But at the very end, there are some examples, right? And this is what this is all about. So you have some example here of what you can do with this tool, right? And there's an explanation of what that that command does. So it's a good idea to come here and take a look and make sure that you have that if you need to go somewhere, you know where to go, right? The next one is the man page for an MCLI examples, which is an MCLI example, which is in my opinion a very useful man page, right? Particularly because it has example number 7, I believe, and number 8. Let me just take you there quick. Okay, so example number 6 is a bond configuration, on how to do a bond configuration. Example number 7 and number 8 are your team configuration and your bridging configuration, right? So you can you can come to this man page and copy and paste this, and you will probably get a decent team interface up and running and a bridge interface up and running. Some be careful here though, because on this example the configuration for your team is expecting you to pass a file with with the configuration for that team in JSON format, right? So obviously there are you can pass on the configuration for your runner a different way, so I will show you how to do that as well. Okay, so the next one is the RHCE sysconfig network scripts, and this is for you're probably familiar with it as well. This is the directory where all the configuration files for your interfaces are created, right? So it's important that you can go in and take a look at the interface configurations that you have. Most of your interfaces are going to start with the prefix IFCFG, and then inside that interface you have the configuration for that particular interface. So we will use it as we go along. And then the next one is the user shared doc, right? The user shared doc is an important directory to familiarize yourself with, right? Here, and I wanted to stop here and show you a quick trick, right? So once we start doing the configuration for the team, network teaming, we will need to know how to configure the runner, right? So if you go to the USR share docs, and you don't know really where to find some information about how to configure the runner for the team interface, and normally I like to do grep and then -d for directory, and this is I'm going to tell what to do when you find a directory, which is recurse, right? And then find runner, right? Runner. So I'm going to pipe this with less because it's probably going to be a very large output. And when you pipe it with less, you get some of the files that have that directive in there, right? If you look closely here, you can probably see this example here, which is a team interface example, and has the right syntax to configure your runner. So basically it's on teamd, example IFCSG, and then number 1 and IFCSG team, right? If you can memorize the directory, that's fine as well. So I would say just go to cd USR share docs, and then you have team, and then you have example IFCSG, then 1. Once you're in there, you have this configuration file, which is an example of a team configuration file. So let's cat ifcfg and then team, and here you have the proper syntax to configure your runner, right? So it's right here. Okay, so perfect. So let's go ahead and start. So that's your toolkit. I wanted, before we move forward as well, just have a quick discussion about IPv6, right? And particularly something about the addressing architecture, some of the rules that you can use to make this IP address a little bit more manageable. So as you know, an IPv6 is a 128 bits address that's expressed in hexadecimal values, right? So we have 8 column separated groups, and you can end up with a very large address. So there's some rules that you can do to make it a little simpler to read for a human, and the rule number 1 is to remove the leading zeros. So if you have an IP address like the one we have there, which is 2001 and then BEF and then 0000000, all those zeros there, you don't have to remember how many zeros, right? So you can just remove the leading zeros, and you end up with a shorter address, which is 2001 BEF, and then you have column 0, column 0, column 0, 45, column 0, column 1. And there's a second rule, and the second rule states that you can take one consecutive group of zeros and you can combine them with one column. And it's important, the keyword one. You can do this only once on the entire address. It doesn't matter how many groups of consecutive zeros you have. You can only do this once, which means that you could take that address and end up writing it like 2001 and then BEF and then column, which would take the 3 zeros and combine them into 2 columns, and then 45, column 0, and then column 1. The reason why you can do this only once is because obviously if you put column twice on the address, the system will have no way to know how many groups of consecutive zeros you had on each of the column. So you have to do it once so the system can properly calculate, right, the number of leading zeros. Okay. All right, so let's talk about our dual stack configuration, right? So let me just get rid of this quick. All right, so first let's take a look at what we have, right? So if we say IPA, we can see that we have multiple interfaces on this environment. So basically, I took my server 1 and I went to my virtualization platform and I added 3 additional interfaces, which is ENS3, ENS37, 38, and then ENS39, right? I'm using ENS33 to connect to the server, so I don't want to disturb my connection. So I'm going to configure first ENS37, right? So I'm going to use nmtui, the text user interface, first to show you how to do a dual stack configuration. So nmtui, text user interface, and you have 3 options here: one, set host name, and then activate a connection, and then edit a connection. I really like this tool because it's very simple. So edit connection, this is where you have the option to add an additional connection or edit an existing connection. So if you edit this connection, you will be able to change the settings for ENS3. But let's add a new connection and associate it with ENS37. So the connection type is Ethernet, and then we will create it. Let's give it a name that makes sense, right? I'm gonna call it con and then ENS37, right? And the device that I'm going to associate it with is ENS37. Typo here, sorry, ENS37. Now, you can see we have IPv4 and IPv6 configuration. So to have a dual stack configuration, you just need to have an IPv6 and an IPv4 and IPv6 configuration. Let's just do this. So you click here, show. The first thing is to change the method to manual, right? Because we're giving this server a manual IP address. And we can add an IP address, and we can say 192.168.212.5/24. We can give it a gateway 201.168.212.2 and a DNS and whatnot, but obviously we don't have to, right? And let's create a IPv6 configuration, same thing. So we change the method to manual as well, right? And then we can add an IPv6 address. In this case, 2001, and then we say column BEEF, and then column 45,
column 0, column, let's say A, B, C, D, and then the subname mask would be 64. Right? We could add a gateway and then add DNS and whatnot. But with this configuration, it should be sufficient for me to have a dual stack configuration finished. All right. So once you do that, then you're basically done. Right? So you create a new connection, and that's it. Let's take a look and make sure that our configuration is working. Right. So we say IP address. Look at the running configuration for IP, and then you see that we have a working. We have the IP address that we set up for this system, and then we have also the IP version 6. So we have a dual stack properly configured. Okay, so with that, then we move to let's do the same configuration, but this time let's use an MCLI. And an MCLI, if you're working with it, one of the things that I really don't like is to have to remember, the long command to do something. But obviously, the tool is very tab friendly, and there's a couple of things that you can do so you don't have to remember all the directives that you need to pass on to configure your network interface. So let's start by running a command that's very important. By the way, we're going to work with connections. So let's say an MCLI connection show. Right, this is the first command that I always run because it gives me a summary of all my connections. So I can see the connection I just created here. Right. So what I'm going to do, I'm just going to delete that connection. So an MCLI connection delete, right? And then we say con ENS 37. Right, the reason, there was no reason for me to delete it. I just want to recreate it. So, as we said earlier, right? So if we say IP link, we have interfaces, 37, 38, and 39, available for us to do this configuration. So let's go ahead and configure ENS 37, right? So we say nmcli connection, and then we need to add a connection. So we say add, and the next thing you need to do is just, by the way, if you click tab, it will give you a list of options, that you can configure. But let's go ahead and say, okay, let's do a type. Obviously, we need to tell what type of connection is this. You can click tab if you're not sure what type of connection. But obviously, as you can see here, you got Ethernet. Or let's do Ethernet. And again, use autocomplete so we don't have to memorize everything. So the next thing is to give this interface a name, right? If you see here, you have an option here to give it a connection name, and it's con name, right? So con dash, and then hit tab again, and it autocompletes. Con name, let's give it a name, and we're gonna call it con ENS 37. Now we have already defined the connection type. We gave it a name. So what we need to do is associate that connection with a physical interface or a device, and the way to do that is using the if command, like you see here, right? So if name, and then we say ENS 37, and that should be sufficient. So we should be able to create a connection. So the connection was added successfully. Let me just clean this up a bit, and let's do an MCLI connection show, and then we have con ENS 37 created again, right? If we do IPA, we see that we have some basic configuration here. So basically, this interface got an IP address from DHCP. All right, let's take a quick look at the directory where the configurations are, which is one of your toolbox. So it's C, sysconfig, and then network scripts. If you do ls, you will see that there is a file called ifcfg con ENS 37. So if we cut that file, we say ifcfg and then con 37. You will see that has the configuration that's on. This is the configuration that's going to come the next time this interface is reloaded, right? But it's the active configuration right now. So it's the boot protocol is the HTTP. So we want to change that. So we want to do the dual stack configuration. So for that, let's say we say connection an MCLI, right? Connection, and I'm going to show you a quick trick. So I'm going to do an MCLI connection show, and I'm going to focus this command
when you focus a command on the interface, you get all the configuration for that interface. But I wanna grab this command to the IPv4. So I see only IPv4 configuration, right? So when I hit enter, you see that there is no IPv4 configuration for this interface. So that's exactly what we're going to do that now. So we need to enter an address, a gateway, and then change the method to auto, right? Don't try to change the method to auto first. That's since you see it first there, and MCLI. Let me show you something. Connection modify. This is the way to do the to change the configuration in your interface. And then we say Connie NS37. If you try to change the connection method to manual before you have an IP address on the interface, the command is gonna error out. So it's gonna tell the error, it failed to modify the connection because there's no IP address. So if there's no IP address, it cannot be set to manual yet. So you have to set your IP address first. So let's do that. nmcli connection modify and then we say Connie NS37 IPv4 dot, and then the way to do is exactly as it is there, right? IPv4 address. So address, and again, it's just tab friendly. So whenever you're not sure, just hit tab, and it will give you a list of possible commands that you can run. So IPv4.address, and then we're gonna give it an IP address 192.168.212.5/24, right? Next thing, we're gonna set up a gateway, and MCLI connection modify, and then Connie NS37 IPv4, and tab just to see what are the options, and we see that we have gateway right there. So gateway and 192.168.212.2. We have a gateway already, and we can give it a DNS name and we can configure the rest of the stuff, but there's really no need for it. So let's clean this up and let's see what we have so far, right? And MCLI, it's very important to check everything you're doing regularly, so you pick up on the silly mistakes very early, right? So an MCLI connection, and then show Connie NS37, and then we're gonna grab that to IPv4. Right? We want to see only what's the IPv4 configuration, and you see that we have an IP address, we have a gateway, but the method is still on auto, right? We need to fix that. So nmcli connection modify Connie NS3 IPv4 dot method manual. Perfect. Okay, so let's take a look at what we have right now. Again, we use the app error to recall the command that we run earlier, and now we see we have manual, we have an IP address, and we have a default gateway. Now the next step is to configure IPv6 settings. So let me clean this up a bit, and we say nmcli connection show, and let's focus on the interface Connie NS37, but we are going to look at IP version 4 information. Grab IPv4, right? IPv6, sorry, IPv6. And again, right, we have the method, we have the address, so we do basically the same thing, right? And MCLI connection modify, and then Connie NS37 IPv6 dot address, right? And then we say 2001 column BEEF column, and then 45 column 0 column, and let's say ABCD, right? And then our mask will be 64. Done. Now we need to change the method to from auto to manual. So modify again con37 IPv6 method, and then we say manual. Alright, so let's take a look at what we have now for IP version 6. We already verified that our IP version 4 configuration is fine, and if we look at it, the IP version 6 configuration is correct as well. So the next thing that we need to do is just to bring down the interface and bring it back out for the changes to take effect. So to do that, we do an MCLI connection down, and then we say the connection name. Now I normally like to bring the configuration back and up on the same line. Just because when you're working with an interface, if you're doing this in a remote system and you shut down the interface, then you have some problems there, right? So it's better to get the habit of bring it down, bring it back up on the same command. That way, if the interface should come back with the new configuration, right? Okay, so we successfully deactivated and reactivated the interface. So if we say IPA, then we will see that we have a ENF37 has already an IPv4 address, and it has an IPv6 address. So that's why you need to configure GeoStack. Okay, the next thing that we're going to do, we're going to talk about teams, right? We're going to talk about teaming. And teaming is a new method for link aggregation from Red Hat. So it's an evolution of bonding, and but it effectively does the same thing. It's just that it's a more modular design. And then there is a module. The design included additional modules, and one of the modules is the runner. Right, the runner is the one that tells the team how to manage the team slaves of the interfaces that have been aggregated. For example, if we configure the team to do load balancing, then it will figure out what sort of load you have on all your interfaces, and based on that, it's going to send traffic through one interface or the other one. You could configure it as round robin, which means that it's going to send some traffic through one interface and some traffic to the other interface. You could configure it as a broadcast, which we just broadcast the traffic out of the interfaces, and you could also configure it as active backup. Right, there are there's another option that you have in there, but you need a specialized switch, for the team to work correctly. But these four are the ones that we're gonna, that you're gonna use the most, right? So let's see how to configure a team. If you remember correctly, and I wanna go back to the file where you can find this configuration example. If you do if you go to the man page for nmcli examples, and then you look for team, or you see that you have a very good example here for the team configuration. Some caution here, because I want to make sure that we're careful, right? So the syntax is very close to what we have been doing. You say nmcli, this is the connection add, and then the type is team, and then you give it a name, right? The connection name can be anything you want. And then you associate it with a physical interface, which in this case, since it's a team, you have to create that physical interface, and you give it a name as well. And then you need to pass a configuration to it, and that configuration is your runner configuration. And I'm going to show you where to find the right syntax, so you don't have to write your own JSON file with the configuration for it. And then you can create after that your slave interfaces and define the master to which these interfaces are gonna belong to. I'm surprised that the type here is Ethernet. We do have an option for team slave, but anyway, we're gonna see how that configuration goes in a minute. And then you just need to bring up the slave interfaces up, and you should have the team working correctly. So let's hop into the system and do this configuration. So an MCLI connection add, and then type. If you tap, it will give you a couple, the options that we have, right? So we have team and we have team slave. That's what I was telling you earlier, right? I'm surprised that that the configuration type is Ethernet on the example, but the correct way to do it is put in team slave anyway. So the type here is going to be team, and then we need to give this connection a name, as we were doing with the other connection. So the name will be team 0, and then associated with an interface. Since this is not going to be associated with a physical interface, we call the physical interface team 0 as well. Now we need to configure to pass a configuration, just to let tell the team how it's supposed to behave, right? And the syntax is as follows: quotes, then brackets, and then double quotes, runner, double quote again, and then column, and then you open another bracket, then double quote, name, double quote, column. I probably lost you already, and you probably close your laptop. But just hang on. I'm going to show you how to so you don't have to memorize this, right? So another double quote, and then you tell the runner what to do. Let's say he's going to do load balance, right? Let me see, load balance. All right, and then quote again, and then close the bracket, then close the bracket again, and then another quote, and then hit enter, and it works. Interesting enough, if you make a mistake here, it's not gonna stop you from doing this configuration. So the configuration is gonna be written to the file with the mistake. So if we do ls right now, you will see that we have a new configuration for an interface, team 0. So if we cat that configuration, we say ifcfg and then team 0, and you will see that it has the runner name and then load balance here. But you need to verify that that's actually working, because if you made it, if there's a typo somewhere, you would not. It's not obvious, right? That there's a problem here. So to do that, you use the teamd control command. You specify the team as team 0 and state, and that's gonna tell you, what's this configuration doing. If you enter the runner configuration wrong, this will be round robin, which is the default. But since it's correct, then it shows us load balance. Now, before we move forward, as promised, let me show you where to find that syntax in case you're on the exam and then you're trying to remember all these columns and all these semicolons. So if you hop into USR share docs, and then I believe we talked about this file already, right? And then you have examples, and then FCFG1, right? If you go to that directory, as we discussed earlier, you have a file that is a configuration example for your team interfaces. So just cut that file, FCFG, and then team, and then you have the syntax right here. You can copy and paste it in your configuration, right? Obviously, if you made a mistake, the way to fix it is as follows. The way to fix it is by, you need to disable the team device. So an MCLI device disable, if you remember, we call the device team 0 as well. So let's disable that device, and I was successfully disconnected. The device is not running right now, so we can vim the etc sysconfig and then network scripts, right? And then here we say ifcfg, and then we look for that team 0 configuration. So we can, if there was a typo or something, we can fix it here. We have runner name or whatever it is. Let's say that we want to change it to, instead of load balance, we want active backup, right? We want active backup. We can save that configuration, and then the next step will be to load that configuration using an MCLI. So an MCLI connection, then load, and then we say sysconfig network scripts, and then ifcfg team 0. And it will be loaded, and then now you can reconnect your interface back, right? So let's just okay. Oh, let's do this. MCLI connection. Up team 0. We could do that as well. So the connection is successfully activated, right? The connection is running, and we can verify using the teamd control command team 0 state, right? sorry, state, and you will see that it changed to active backup as we change, as we edit the file. Okay, so we have already the interface configured. There's a couple of things that we need to do. We still need to add team members to this interface, and we're gonna get there. But if we do IPA, you will see that this team0 interface, let me see if I find it. Team0 interface, I mean, there's nothing in there, right? So let's add some, the state is down, and the state is down basically because the device is down. But let me just reconnect the team0, right? Okay, so what we need to do next is to add team members to this interface, right? So let's do that right now. Okay, so let me clean this up. nmcli connection add. By the way, before we go there, let me do IP link, right? And we're going to add ENS38 and ENS39 to this team, right? So nmcli connection add type, and then that will be team slave, and we give it a name, connection name, team0 ENS38, right? And then IF name ENS38. Then we need to define the master. The master will be team0. All right, so the connection was successfully created, and let's create a second slave for ENS39. 39, and the interface, ENS39 as well. And okay, so we have the two interfaces created already. So let's bring those interfaces up. nmcli connection up team0 ENS38 and 39. All right, so team D CTL team0 state. And as you can see, we have the configuration as active backup, and then the active port is ENS38. Okay. One thing that I want to point out as well, as you can see, my team0 interface here has a TCP/IP configuration. So the only thing is that right now is configured as for the HTTP, but we can certainly sit down and add an IP address to it. So an MCLI connection, as you remember, modify, and then we say team0, and then we say IPv4 dot address, and 192.168.212.10/24. Let's add a default gateway. And then 192.168.212.2, and we set the method to manual as well, as we discussed earlier, right? Sorry, the method to manual. All right, nmcli connection down team0. So what this is gonna do, this is interesting, right? Let me show you what it does. So if you bring the connection team0 down, right? Let me show you, team0 down, it is gonna bring your team slaves down as well, right? So if we bring the connection team0 up, right, the master is waiting for slaves, which is this shows how the dependency between the team master and the slave work. Taking down the master would take down the interfaces, the slaves. But bringing the master back up doesn't necessarily bring the slaves back up. So to bring it up, you need to nmcli connection up, and then team0 ENS38, then nmcli connection up team0 ENS39, and that should properly reactivate the slaves, and your team should be working properly. So team D control and then team 0 state, and that's working fine as expected. Okay, so that's a team configuration. Remember to refer to the main and MCLI examples, right? Because this is going to give you a lot of information on how to do this. The next will be our bridge configuration. So for our bridge configuration, what we would do is, if we do IP links, we have this ENS37, so we're going to create a bridge interface, and then we will add only one interface to that bridge. So the bridge interface is really used for virtualization. So you're basically creating a bridge in your server, so you can have a shared broadcast domain with with all the systems. So let's say that you have running KVM, or you're running OpenStack or something like that on your server. You want to have your VMs connected to a bridge interface, so you can communicate with the interfaces on your server, or even with the network, right? And we're going to talk about some more advanced configurations in a second. But the bridge configuration is pretty much it's very similar to your team configuration. So you do an MCLI connection add, and then we say type, and the type is bridge. So we're going to create a bridge, right? And then we just give it a connection name. Obviously, we're going to say BR0, right? And then the interface name, we're going to go BR0 as well. That's it. We hit enter, and the connection, BR0 was successfully added, right? The only thing is that it doesn't have a slave. So we can do an MCLI connection add, and then the type is, again, you guessed it, is bridge slave, right? It's a bridge slave, and this time we're going to call it BR0 ENS37, because we will associate the device ENS37 to this bridge 0. So IF, and then we're going to say IF name. I'm sorry, bridge slave con name. There was a mistake there. And then con name, I would say BR0 ENS37, right? Now we need to associate this connection to a device, in this case ENS37. Now, now we need to tell, obviously, this interface who's gonna be associated with. So same thing, master, and the master we tell them to get connected to bridge 0, right? And the connection was added successfully, and at this point we can bring the connection up, and MCLI connection, we bring the slave up, connection up, then BR0 ENS37. The connection was successfully created. My system is complaining a little bit because it detected a bridge, so he's assuming that I'm using it to capture packages from this laptop. So it's a precaution, right? So now we created the bridge interface, and we already created as well we associated an interface with it. The way to verify this is a command bridge control, right? And bridge control has a couple of options, so we can specify what we want to do is just show, right? Show the bridges that we have, and as you can see, we have a bridge BR0, and the interfaces that it has is ENS37. So I have an interface there connect to my bridge. A spanning tree protocol is enabled, so I have a working bridge. Now it's worth to note, and I promise you that we're going to talk about some more advanced configuration. So it's worth to note that the network manager only supports Ethernet interfaces to be connected to the bridge. So you cannot, for example, add your team to the bridge using the network manager. But it's obviously a configuration that you might want to do, right? So let me just hop into the ITSI, and then sysconfig network scripts, and take a quick look at the BR0 ENS37, right? So it's cat IFCFG BR. And the way to associate this interface with a bridge is by adding this directive here, right? So what we're going to do, we're going to try to get the team interface into the bridge. So to do that, we need to first disable the network manager, because this is not a supported configuration by the network manager. So we say systemctl and then stop network manager, which is capitalized for some reason. So and then we need to disable it. Obviously we don't want it to reboot, right? Disable and remove the links. So now the network manager is stopped, and it's not, we're not using the network manager to manage our network. So at this point we can, let me just clean this up a bit. At this point we can take the bridge interface and add it to the bridge. So again, let me just show you how to do the configuration quick. You cat IFCFG and then BR0 ENS7. This is what you need to add with the interface configuration for this to work. So let me just copy that to avoid having to remember anything, and then we're going to edit IFCFG and then team0, and at the end of the configuration, that's when we're going to associate this interface with the bridge. So just paste this here, bridge equals BR0, right? That's the right way? Yeah, bridge equals BR0. Alright, we save this, bridge equals BR0. Let's just cat this just to compare it, make sure everything is fine. Yeah. So now the next step is just restart the network services. So systemctl restart, right? All right, so it's taking a little bit because we have a lot of configuration, right? So let's just let it run for a little while, and let's go back here and quickly, before we go back, talk about the lab. So the lab, okay, so this is complaining a bit. So the lab is a very simple configuration. So it's telling you to take server 1 and add 3 additional interfaces, and then to configure a team named team0 with 2 interfaces associated with that team, and then configure your team0 interface with an IPv4 address, and I'm giving you a suggestion here of 192.168.0.200 and a IPv6 address of 2001 and BEF 450 ABC, right? And then it's asking you to configure a bridge interface and add the 3rd interface to the bridge port. That's it. So, go ahead, prepare your server 01, remember to add 3 additional interfaces, and then go through these steps, and then just have fun with your lab, right? As usual. Okay. Alright, so this fell. Let me take a look and see what's going on. Right, so it's telling me that there is no IP information for BR0. This is probably talking about, let me just do a -L, right, so I can take a look at the information. So, sorry, status minus L, and it's telling me, let me see if I find it. I lost it. So yeah, it's telling me that I couldn't determine the IP information of bridge 0. This is probably because when I was restarting, the system was asking me if I was going to, if I want to allow the bridge to come back online. I probably missed it when I was talking about the other stuff. But just give it a try, and it should work just fine. So let me just show and see. This bridge, that this didn't come back up. So let me, let's just reboot and see how that goes, right? Let me hop into the virtual machine itself, make sure that this is working fine. All right. So yes, this is fine. All right. So password, then as you can see, we run the brctl show, and now we have team 0 as one of the interfaces. So the error that you saw earlier, that the network service was not restarting, was basically my system, that it detected a breach, and it was giving me a warning telling me that there might be someone breaching my physical connections and trying to look at the traffic from my laptop. So this is obviously, it gives me that warning just in case it's a security problem. But I just rebooted it to see the error again, sorry, the prompt again asking me for the admin password to authorize this, and it just worked fine, right? So again, just make sure this is back to the lab. Make sure that you go through this task. This should be sufficient for you, and especially you guys taking the exam. This task should be enough. But obviously, that last configuration that we did over there, it's not a configuration that you're going to do a lot, but just in case you need it one day, just play with it. And remember, this lab is not going to blow up or anything, so just make sure that you can that you find all the issues that you can find right now. So when you go, when you're working on a client, or even taking the test, you already you already know what to do to troubleshoot. So I hope it was informative, and thanks for watching.